In this slide, we have two special right triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle. I've created a supplemental video attached to this section on special right triangles. So for a detailed presentation on that subject, please refer to that video. Here, we're just going to do a quick overview. Let's start with the 30, 60, 90 triangle. Of course, we have a right angle, and opposite the right angle is the hypotenuse. We have two acute angles. Opposite the smallest angle is the short leg, and opposite the large angle, large acute angle, is the long leg. And again, as our previous video demonstrated, that if I'm given the hypotenuse, the short leg is equal to the hypotenuse, which is 2, divided by 2, which is 1. Then the long leg is the short leg, which is 1, times the square root of 3, which is the square root of 3. This is already illustrated in the diagram, but this is just a quick overview. Let's continue to the 45, 45, 90. Here we have two congruent acute angles. Therefore, I know that this is an isosceles right triangle, which makes my two legs congruent. Again, I have a right angle. Opposite that is the hypotenuse, and these two congruent legs are known as the legs. To solve for the legs, I know that the hypotenuse, if that is given to us, is the hypotenuse divided by the square root of 2, and in this situation is 1. Knowing one of the legs, since they are both congruent, that gives me the value of the other leg. Again, for further demonstrations, please refer to the video on special right triangles attached to this lesson. Our next slide shows a chart of function values of special angles. And it's obvious that from our previous slides and our extra video that these angles are the 30-degree angle, 45-degree angle, and 60-degree angle. And what we have are associated values for our 6 trig functions. What I'd like to do is demonstrate how these values are generated. The easiest way to do that is to take a look at a circle on a coordinate plane. And let's identify the parts of the angle that I generated. We have an initial side, which we know is our x value. We have a terminal side, which we know to be the r value, and also know that this is opposite our right angle, that this is going to be our hypotenuse. And our vertical that we dropped is going to be our y value. What we'll do here is we're going to let r be 1. We can let it be any value we want, but 1's the easiest number, so let's let that happen. We'll also identify the angle of theta to be equal to 30 degrees. It's one of our special angles from the chart, and that's the one we need to use. If that's true, then I know that these 3 angles of the triangle must add up to 180. Since I have 90 and 30, this leaves our opposite angle to be 60 degrees. Well, there's our special right triangle, which is a 30, 60, 90 triangle. And again, from our previous slides, we know if I know one measure of a side, I can determine the other 2 measures. In this situation, since I know the hypotenuse, I can determine the short leg, which is opposite my smallest acute angle. So my y value is my short leg, and my x value is my long leg, since it's opposite the largest acute angle of 60 degrees. Let's recall that a short leg and a 30, 60, 90 triangle is the hypotenuse divided by 2, which makes my short leg equal to 1/2. My long leg is then my short leg times the square root of 3, which makes my value for my long leg to be the square root of 3 over 2. Let's recall our trig functions. From previous sections, we know that the sine of theta, and here 30 degrees, is going to be y over r. But I know that my y value, which is my short leg, is 1/2. So 1/2 for y divided by r, which is 1, is equal to 1/2. Cosine of theta, and here 30 degrees, is going to be x over r. And here, my x, or long leg, is equal to the square root of 3 over 2. So this is the square root of 3 over 2 divided by my r, which is 1, which is the square root of 3 over 2. Tangent theta, or 30 degrees in this situation, we recall is y over x. My y value is 1/2, which is my short leg, over my long leg, which is x. So that's going to be the square root of 3 over 2. When I simplify, this gives me 1/2 divided by the square root of 3 over 2, which equals 1/2 times 2 over the square root of 3, which equals 1 over the square root of 3, which I need to rationalize by multiplying by the square root of 3 over 3, which gives me the square root of 3 over the square root of 3 times the square root of 3 is the square root of 9, which is 3. So my values, sine of 30 is 1/2, cosine of 30 is square root of 3 over 2, and tangent of 30 degrees is square root of 3 over 3. Let's go back to our chart. Here, it shows that I have the sine of 30 degrees is 1/2, the cosine of 30 degrees is the square root of 2, and the tangent of 30 degrees is the square root of 3 over 3. I can generate the reciprocal functions just by finding the reciprocals of sine, cosine, and tangent and get the following values. For the values of 45 and 60 degrees, they are done in similar manners. I won't work through all of them, but I'll show you just the initial stages. For example, another circle generated in a coordinate plane. I have an initial side. This is my x value. Drop a vertical. It gives me my y value. And my r, which will generate as 1. My theta here would be 60 degrees, which would leave my other angle at 30. I would then follow the same procedures in a 30, 60, 90 triangle and solve for my x, y, and r, and substitute in for my sine, cosine, and tangent, and then the reciprocal functions. For the next one, I would do the same thing, use an initial side, which would be x, my terminal side would be r, my hypotenuse, drop a vertical, which is my y. And here my theta would be 45 degrees, which would give me my isosceles right triangle. Again, substitute in and solve those values for sine, cosine, and tangent and reciprocal functions, and you would generate the previous chart. I will put that chart on the resource page of our group page for further review. Here is your assignment. Please refer to the discussion board for any questions.